Here is the demonstration for oxidation reduction. I have here a 1 liter beaker. I'm going to fill it with about 500 mils of DI water. Next, I'll be adding phenolphthalein indicator. Our phenolphthalein indicator is clear when in water. And now next, I'll be taking a piece of sodium metal and I'll be adding it into my beaker here. The sodium metal is stored in mineral oil, that way there are no moisture leaks. I have here a mesh that is going to be going over top my beaker once I add the metal. I have my tweezers in order to collect my metal. Here is my piece of sodium metal. Now we will wait and see if there is a reaction. And with that, you can now tell if there was a presence of reaction or not. Here I have my beaker for my reaction with calcium. I'm going to add some water to it. Next, I'm going to be checking the pH of my water with pH paper, so then we can compare before and after. So here I'm sitting at an orange, about a 5 for my pH paper. First, actually, I need to add my phenolphthalein. I'm just going to add several drops. Next, I'm going to be adding my calcium metal. I have prepared a piece that has a more silvery surface, as the metal should have. You can see the chalky white oxide layer on the side, and then my more silvery shiny surface that I have sanded. And it is reacting quite vigorously. There are a lot of bubbles forming. Now we are moving on to our reactions with other metals with water. We are going to be using tin metal, copper metal, iron in the form of nails. We have zinc, magnesium. All 5 of these will be reacted with DI water. To set up for my reactions of metals with water, I'm going to be taking my DI water and adding it to my beaker here. Then in my beaker, I'm going to be adding several drops of phenolphthalein indicator so that we can trace any reaction later. This will help us identify any pH change. Now I have prepared my test tubes for each of the reactions. Now I'm going to be adding 2 mils of water to each of my test tubes. And now that I have my 2 mils of DI water added to each test tube, I can then add my metals. I have here my iron nails. I will grab one out and drop that into my water here. Next, I have tin metal. Next I have my zinc, copper, and lastly, magnesium. Now we will wait for 10 minutes and observe any reaction going on in the test tubes. We already can see our magnesium is reacting. As you can see, the surface of the metal is starting to show pink from our indicator. Our zinc as well is reacting and showing pink on the surface. However, it is much slower than our magnesium, and I cannot see any reaction going on with the three remaining metals, are iron, tin, or copper. There are some minor bubbles forming on the surface of our magnesium. For me, it is very easy to observe it on the sides of the strip of metal. I cannot observe any bubbles forming on our zinc, and I would not expect the zinc to react with water, but as we can see by the faint presence of our indicator, there is a very minor reaction going on. And now we will let these go for 10 minutes and record our observations. So after 10 minutes, as you can see here, our magnesium has reacted a fair amount with our water. Our zinc is very questionable. There are very minor patches of it that are reacting with the water, but I would not say that this is any form of reaction that we would quantify as significant. And then our iron, tin, and copper have no reaction. Next up on our reactions of metals, we are going to be taking our four metals that didn't react, or in our case of zinc, really did not show significant signs of reaction with water, and we are going to be using 3 molar hydrochloric acid now instead. So since our magnesium showed significant enough signs of reaction, we are not including it here. And now I will take my 3 molar hydrochloric acid and add 2 milliliters to each test tube. And now I have saved my metals that did not react with my water and dried them. Now I need to be very careful because our tin and our zinc look very much alike. So I have made sure that I know which ones are which. So to start, I have copper. Next, I have my tin metal. Then my iron nail. And lastly, my zinc metal. And now, just observing, I can see immediately my zinc has bubbles forming on it. Our iron does not appear to be reacting. Our tin does not appear to be reacting. And our copper does not appear to be reacting. We will let this go for another 10 minutes, and then we will come back and see. Coming back and observing, after about 5 minutes, still our zinc is reacting quite vigorously. There are some bubbles forming on our iron, nothing on our tin, nothing on our copper. So at this point, I'm going to add a drop of phenolphthalein indicator into each in order to help reveal any pH change that is happening. As you can see, since we are using 3 molar hydrochloric acid, it is not very easy to see or indicate any form of major pH change in our samples. All we have to go by is observing and watching for any other physical signs. Now that 10 minutes has passed, our zinc is still reacting rather vigorously. Our iron is reacting modestly. No reaction from tin, and no reaction from copper. Now we are moving on to reactions of metals with our other metal salts. So to start, I'm going to be taking the 4 metals that did not react with water. I'm going to be adding 0.1 molar sodium chloride to see if it is able to bump out the sodium ion. So just as before, I will take and add 2 mils of my sodium chloride to each. Now I will take and add my metals, copper, tin, iron, and zinc. And now we will let these react for 10 minutes and record our observations. Initial observations, our zinc, iron, tin, or copper is reacting. Now that several minutes have passed, does not look like our iron or zinc, tin, or copper are reacting with sodium. Several more minutes have passed, still no observable reaction on any of our metal samples. Several more minutes have passed, looking at each of our metal samples, there is still no reaction with sodium chloride. Now that 10 minutes have passed, we will look at one last time all of our metal samples, and after observing all of them, there is still no reaction with sodium chloride. None of our metals have reacted with the sodium chloride solution. For our next solution, for our reactions with metals, we are going to be using calcium chloride. It is again 0.1 molar, as you can see here. Just as before, I will be adding 2 milliliters to each of my test tubes. Next, I will be adding my metals. First, I have my copper, then my tin, iron, and lastly, zinc. Now I will let these sit and react for 10 minutes and observe any signs of reaction. Now that we are about halfway through, coming back and observing each of our samples, there does not appear to be any signs of reaction on any of our metal samples. Now that our 10 minutes have passed, a final observation on each of our metals. None of the metals show any sign of reaction, so there is no reaction of any of our metals with calcium chloride, and this is to be expected based on the reactivity series. Next up in our reaction of metals with solutions, we're going to be using 0.1 molar magnesium chloride. Just as before, we will be adding 2 milliliters of our solution to each of the test tubes. And then we will be adding our metal samples. First copper, then tin, iron, and zinc. And now we will watch for any signs of reaction. Initial observations, there does not appear to be any reaction happening on any of our metals with the solution. We will let this reaction run for 10 minutes. After 10 minutes has elapsed, looking at each of our samples, there is still no visible sign of reaction whatsoever. This is as we would expect from our magnesium chloride solution with our metal samples. Next, we are going to be using zinc chloride. Again, 0.1 molar zinc chloride. Just as before, we will be using 2 mils of our solution into each test tube. Adding in our metals, copper, tin, iron, and zinc. We will now let our metals sit and record any observations. Initial observations, there is no sign of immediate reaction on any of our metals. Now that about 5 minutes has passed, observing each of our metals, copper, tin, and iron show no signs of reaction. However, our zinc does have some bubbles forming on its surface, showing that there is some form of a reaction between our zinc metal and our zinc chloride solution. Coming back after 10 minutes and observing each of our solutions, there is still no reaction in our iron, tin, and copper. However, our zinc is bubbling, showing that our zinc is reacting with the zinc chloride, which is not necessarily what we expect, but is possible and does make sense. Next up for our solutions, we are going to be using iron chloride, our 10th molar iron 3 chloride solution. As you can see, it is a brownish color inside of our bottle. 2 milliliters into each of our test tubes. As you can see in our test tube, the iron chloride solution is yellow. So in this case, It may be slightly more difficult in order to view the reaction, but if there is any signs, we should still be able to see it. Add our metal, copper, tin, iron, and zinc. Now we will sit, let them react. Initial observations. There does not appear to be any form of reaction with any of the metals initially. Now coming in and observing after about 5 minutes, we can see that our zinc is forming bubbles down in our tube, showing that there is reaction. There does not appear to be any reaction with iron, tin, or copper though. We will let this sit for another 4 or 5 minutes and then record our final observations. Now that our 10 minutes has passed, observing our samples, there still only seems to be reaction in our zinc sample. There does not appear to be any reaction with iron. Next up in our reaction series is tin chloride. We are going to be using 0.1 molar tin 2 chloride. Just as before, we will be adding 2 milliliters of solution to each test tube. Now we will be adding our metals, copper, tin, iron, and zinc. We will let these sit for 10 minutes and record our observations. Initial observations, our zinc has immediately begun precipitating tin from solution. Iron, tin, and copper do not appear to have any reaction. As you can see, on the tin, immediately there is a large collection of tin crystals forming on zinc. After several minutes looking at our solutions, does not appear to have any reaction of our copper, tin, or iron. However, now there is even more crystals forming on our zinc. So much so that we actually have almost filled our test tube with tin crystals. At the end here, there is still no reaction between our iron, tin, or copper. However, still our zinc has a significant amount of crystals forming on it, to where if I reach down with my tweezers, I can pull out my zinc sample, which actually has become thinner. You can see up here it becomes thinner from top to bottom, and then we are left with a large ball of tin crystal. For our last reaction here, we are going to be observing copper chloride with our metals. We'll be using 0.1 molar copper 2 chloride. As you can see, our copper solution is a light blue. Adding 2 milliliters to each of our test tubes. Now we will take and add our metals, copper, tin, iron, and zinc. Initial observations, looking at zinc, there appears to be some precipitate forming on the surface of the metal. Our iron nail as well, instead of being the typical silver or rusty color, it is turned orange, as has our tin. Our tin now has a layer of copper coating it, and then our copper metal appears to have no reaction. I will let this sit for several more minutes and come back and make final observations. Coming back after several minutes, there is copper forming on our zinc, as you can see from the crystals growing off on the side. Our iron as well. It is hard to see on the camera, but the iron is turned completely orange from copper crystals growing along its surface. The tin as well has changed color. You can still see the original in silver, but then down below it has a thin layer of copper coating the bottom, turning it orange. Coming back now to finish up, observing each of our metals, our zinc has gathered quite a bit of crystals along its surface, and it is no longer a silvery color that we would expect. It has become almost blackish, as the mix between silver and copper or the silvery metal of the zinc and copper is on its surface. Our iron nail looks almost as if it has completely rusted, as its surface was coated with copper. Our tin sample again has grown crystals on its surface, changing its color from its typical steel silver metal sheen to orange. And as you can see, it has actually grown a little wider from the crystals. And then our copper does not show any true signs of reaction. There may be a slight amount of additional sheen on its surface, but not enough for me to determine if that is from copper crystals being pulled off or attaching to the surface, or if it is just from the solution itself. And that concludes our reaction of metals with metal solutions.